Hi, my name is Teja and my registration number is 21BCE1329. So today we'll be doing a short review on project tree of Nand2Tetris. So before getting on to the program, what is the going to be the overview of the project tree? So we'll be using the chips from project 1 and 2. In project 1, we have used basic logical gates, that is AND, OR, XOR, and so on. Then project 2, we build using the project 1 gates. We have built half adder, full adder, half subtractor, and all, and data flip flops as well. So our goal here is we'll be building a 1-bit chip, 1-bit register, then a 16-bit register, then 8-bit 8 RAM, RAM of 8-bit byte, then RAM of 64, RAM 512, RAM of 4 kilobyte, RAM of 16 kilobyte, and program counter. So first is 1-bit register. So I'll be showing the code. So this is the code for 1-bit register where we use the logic of mux from project 2, and then we use the data flip-flop for producing the output. And I'll be running the simulator now. So here's the simulator. Now I'll load the chip. So the chip is will be loading the 1-bit register, and then we'll be loading the test script for it. And now we'll just click the run button. So since the test case is a bit long, what we'll do, we'll speed up the test case by dragging this arrow to fast. And here what's going on is the clock, we're clocking and unclocking. We're setting the input as 0, then we're setting it to 1. We're loading as 1 and 0. So basically the register is getting clocked and unclocked at the same time, and it produces output based on that. So here's the output for it. As you can see here, we just clocked, unclocked, clocked, unclocked. Then moving on to 16-bit register. So the code here is pretty simple. We'll be using the 1-bit register logic in the 16-bit register. So here's the code. And it's the same logic. It's the same logic what we used here. Only difference is we'll just use bit for each. We'll be initializing an array of 16-bit, size 16, and we'll be using it on each individual bit. So now we'll run the simulator for it. And here's the test script. And now we'll run. The logic is same as the for 1-bit register. Only thing is we are doing it with each individual bit. So the execution will be a bit longer. And here's the output. I have pasted the screenshot output file here as well, so you can just refer it. And now we'll be doing for RAM. So here's the code for RAM. We'll be using the logic of the register, the 16-bit register in here. And now we'll just execute it. Basically, we have built a RAM here. So we are building a RAM in a software, you're just executing it. And here's the output. So here's the RAM 64. So I'll be showing the code for it. So as you can see, we use the Dmux 8-way, which we used even RAM 8. That was, I think, we built in project 1, and here we'll be using we'll build RAM 64 based on using the previous RAM. That was RAM 8. So now I'll be running the simulator for it. Yeah. And now the test script. So keep in mind that this is actually 64 registers in it. So in RAM 8 we had 8 registers, and RAM 64 will be having 64 registers. So the program was successfully executed. So with the output, this is the output here. Now moving on to, we'll be executing RAM 512 using the logic of 64 registers. So here's the code. It's the same logic, but we are basically building one RAM on top of the other. And now we'll run the simulator for it. The program execution will take time because we have loaded so many test scripts. And as we use more RAM of more higher size, the complexity increases. The program was executed successfully, and this is the output. Now moving on to RAM of 4 kilobyte. So we'll be using the logic of RAM 512 to build RAM 4K. It's pretty much the same thing. It's exactly the same thing. It's just we have to change change this part of the segment. That's it. And now we'll run the RAM 4K simulator. We'll load the script and execute. So the execution was successful, and now we'll see the output. So this is the output. Now moving on to RAM of 16K, we'll be using the logic of 4K to build 16K. So here's the code, and now we'll run the simulator. So this will take a bit longer because you're executing basically. See, we designed a program for 16,000 registers, so it will take a time. So the code was executed, and here's the output. Now next is the program counter. So the code is a bit different because the logic is also different. So what we will be doing is we'll be using the add 16 logic from project 1, and we'll be using the mux 16, which is also logic from project 1. And at last for time stepping, we'll be using the RAM 8 logic for it. So here's the code. So we'll be executing it. So we'll take pc.htl and put a script pc.tst, and now execute. So the program was executed successfully, and now we look at the output. And as you can see, this is the output. So I have pasted a screenshot of the output here as well for reference. And so this is it for the project tree of Nand2Tetris. Thank you.